I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on basics of antenna theory. So, what is an antenna? So, antenna is a device which converts the guided waves present in a waveguide, feeder cable or transmission line into radio waves traveling in free space or vice versa. So, it is a passive structure that serves as a transition between a transmission line and air used to transmit or receive electromagnetic waves. And also we can say that it converts electrons to photons of electromagnetic energy, and that it is a transducer which interfaces a circuit and a free space. So this picture represents the antenna structure and how it acts as an interface between guided wave and free space wave. So the left side we have a generator or transmitter, and from the generator the wave is generated, electromagnetic wave, and it is guided through a transmission line. So with the transmission line an antenna is attached. So here the purpose of this antenna is to convert the guided wave from the transmission line to free space waves. That is, it converts a plane waves from transmission line to the spherical waves into air. And at the receiving side, the case is vice versa. So at the receiving side, the antenna is a structure which receives electromagnetic waves, and here also it is used as a transducer between the spherical wave and the guided wave. It converts the spherical wave from the air into guided wave to the transmission line, and from the transmission line the electromagnetic wave is extracted and it is given to the receiver. So an antenna is a transition device between guided wave to free space wave and vice versa. So if we see the role of antennas, the four important roles, it acts as a spatial filter, because the antenna which transmits the signal at desired frequency, and it suppresses the waves at undesired frequencies, and it also acts as a polarization filter, and it has polarization dependent sensitivity. So some antennas will radiate the waves in horizontal polarization, and some antennas will radiate in vertical polarization. Some antennas will do the elliptical and also the circular polarization. So it acts as a polarization filter, and it acts as an impedance transformer. For example, a feeder cable or a transmission line will have an impedance 50 ohms, and the free space impedance is 377 ohms. In between these two, in order to convert the 50 ohms to 377 ohms, the antenna is used, and it is a impedance transformer, and it also used as a propagation mode adapter from the theory of converting free space to guided waves. And there are variety of antennas are available. So some of the antennas, very important antennas, are given in the picture. It may be end-fire antenna, loop antenna, dipole antenna, slot antenna, and aperture antenna are some examples of the different types of antenna. And now an important concept in antenna theory is isotropic antenna. It is a hypothetical antenna. It does not exist in real life, and it is used for only the measuring bar for comparing the antenna characteristics with real time antenna or practical antenna. And the isotropic antenna, so it is a point source which occupies the negligible space and has no directional interference, and its pattern is simply a sphere, and it has the beam area of isotropic is 4 pi steradians. And there are three different types of antennas or radiators. One is the isotropic radiator. We know that it is a hypothetical lossless antenna having equal radiation in all directions. And omnidirectional radiator is an antenna essentially a non-directional pattern in a given plane and directional pattern in any orthogonal plane. And directional radiator is the antenna having the property of radiating or receiving more effectively in some direction than in others. Usually, the maximum directivity is significantly greater than that of a half-wave dipole. And the antenna parameters and antenna analysis is always done in spherical coordinate system, because the antenna radiates spherical waves, and we are assuming the spherical coordinate system is useful for analyzing the antenna parameters. And next is the important parameter is called radiation intensity. Radiation intensity of an antenna in a given direction is the power per unit solid angle. And the radiation pattern, this is a very important characteristics, the primary characteristics of an antenna. It is a graphical representation of antenna radiation with respect to direction, and it is three-dimensional graphical representation of the far field radiation properties of an antenna, and it is the function of space coordinates. And there are two types of field pattern. One is far field pattern, near field pattern. And far field pattern measures the radiation near at a far distance from the antenna, and the near field pattern depicts the fields near to the antenna. And typically there are two planes in antenna radiation pattern measurements. One is E plane and another one is H plane. And there are the diagram represents the radiation pattern characteristics. So it has 3 dB beam width, side lobes, nulls, front to back ratio, gain, maximum signal position. So main lobe is the maximum radiation lobe. Side lobes are the lobes in unwanted or undesired directions, and in between the 3 dB point of a major lobe represents the beam width. It is called as 3 dB beam width, and if the beam width is measured in between two half power points of the major lobe, it is called as half power beam width. And side lobes, we know it represents the lobes at unwanted direction. They represents the radiation loss, useful radiation loss. And the nulls are the points of zero radiation. Front to back ratio is nothing but the ratio of radiation in forward direction to the reverse direction. That is the backward direction. And gain represents the antenna's useful radiation, and the gain is related to the directivity as G is equal to KD, and the maximum signal position. So the antenna important parameters, as we discussed already: main lobe, half power beam width, and first null beam width, and the side lobes or minor lobes. And antenna directivity is another important parameter. It represents the antenna's ratio of antenna's maximum radiation intensity to the average value of a sphere as observed in the far field of an antenna. And it is a dimensionless. It is value is always greater than or equal to 1. So the directivity value is always in between 1 to infinity. It is the D is equal to P of theta comma phi max, that is maximum power density, to the average power density P of theta comma phi average. And the directivity is related to the beam solid angle is 4 pi by sigma A. For omnidirection, for isotropic radiation pattern, this beam solid angle sigma A is equal to 4 pi. So 4 pi by 4 pi is equal to 1. So the directivity, the optimum value is 1. And next important parameter is gain. Antenna's gain or power gain is a key performance which represents the antenna's directivity and also its efficiency. And as a transmitting antenna, the gain describes how well the antenna converts input power into the radio waves headed in a specified direction. And at the receiving case, the gain describes how well the antenna converts radio waves receiving from specified direction into the electrical power. So when there is no direction is specified, gain represents the peak value of the gain. And the radiation pattern is a plot of the gain as a function of direction, and it is related with the efficiency factor as G is equal to KD. So here G is the gain, D is the directivity, K is the efficiency factor of the antenna. And there are two important gains, one is power gain and another one is the directive gain. And the last parameter we are discussing in the antenna parameters is the bandwidth. Bandwidth is the fundamental antenna parameter. It describes the range of useful frequencies the antenna receive or transmit the energy perfectly. And typically the required bandwidth is one of the parameters used to select the antenna type. And for example, there are many types of antennas with very small bandwidth. These antennas cannot be used in broadband applications. So now the assessment is units of radiation intensity. We know it is watts per unit standard angle. The radiation lobe containing the direction of maximum radiation is called the major lobe. Thank you.